Mortality projection. So this chapter has a very less mathematical typing and more of theory in this chapter. Still, I'll make you all do some exam style questions which are there. Discuss a major difficulty that is present in a three-factor age code mortality, but it's not found in either an age or age period model. Again, this is a theory, so I'm not discussing. The following Lee Carter model has been fitted into mortality covering two age groups from and a 41-year time period from 1990 to 2030 inclusive. Define in words or symbols. Again, theory. State the constraints that are normally imposed. Theory. In this model, KT has been said to cover a 41-year time period from 90. Where ET is this? Identify the numerical value of KT ignoring error terms. So here we have to now find numericals. So I'll just go to the solutions and show you the numerical values of KT. This is also a very less part. In part C, so KT is a linear function whose value is some this. So KT, just write what is required in mathematical typing. So alt equals to K underscore T is equals to 0.02 into T minus 2010. Okay, so where KT then gives 0.4, 0.38, putting the years, so on to 0.3 minus 0.38. Okay, for T equals to 1991 to 2029 2030. So this is the values which we are getting respectively. Next part, if you see, effective trend is different ages, effective time on different ages, again theory. Then complete the specification of the model. This is there, so we'll do this, complete the specification of the model. Let's do this. As mortality rates are improved, both the values of B60 and B70 are positive. So B60 plus B70 is 1. So B60 plus B70 is equals to 1. So therefore alt equals to 3B70 plus B70 is equals to 1. So alt equals to B70 is equals to 0.25 and alt equals to B60 is equals to 0.75. Okay, this was told to us. Now coming down, so next line we have our value for sigma x, AX. AX is the value of ln m hat, m backslash hat space underscore, in brackets you write x comma t and brackets close. Okay, brackets close when k underscore t is equals to 0. Okay, and this happens when t is equals to 2010. So alt equals to a underscore 60 is equals to ln of m hat, ln of m hat underscore 60 comma 2010 brackets close is equals to ln 0.00176, which is equals to minus 6.34244. Okay, and alt equals to a underscore 70 is equals to, again same thing, do not writing, copy paste and just turning this to 70, removing the values from here, 0.01328 and changing the value from here also, that means minus 4.32150. Okay, and the last part is projected values. Only this part again has numerical portions. So alt equals to K2025 is equals to minus 0.02 into 2025 minus 2010. So which is equals to minus 0.3. Okay, so at 860 then alt equals to, again we need ln, So do not write when something is written already by you. Okay, so A60 plus B underscore 60 K underscore 2025 is equals to minus 6.34244 plus 0.25 into 0.75 into minus 0.3, which is equal to minus 6.56744. Okay, so therefore this value without ln so just ln is not getting copied, I'll copy this, is e to the power of minus 6.56744, which is equals to 0.00141. And similarly for at age 70, I'll just copy these two lines because I need these two exact lines, and I'll make the necessary changes. This is 70. Okay, this is 2025. Okay, and then A60 B60 minus 6.3 minus, both of this becomes 70 minus 4.32150 plus 0.25 into minus 0.3, and this value becomes minus 4.39650. So M702025 is equals to minus 4.39650, which is equals to 0.01232. Okay, simple. And then disadvantages of Lee-Carter model is given to us, which we don't need. Next question 12.3, which I am doing, is just the writing the formula. This is a derivation which is most unlikely to come because they've said direct questions may not come, or if they come also they'll come like in MCQs for selection. Okay, but mostly direct questions they have said they'll avoid. Okay, so rearranging the original model, I'll just do this because this contains mathematical typing which will help you all. ln of e d underscore x comma t brackets close is equals to minus ln e to the power c underscore bracket x comma t. Okay, e to the power c underscore bracket x comma t come out of the highlighted region, a plus bt plus ct square. Okay, so alt equals to implies sign ln in brackets e d underscore brackets x comma t divided by e to the power c underscore bracket x comma t bracket close is equals to a plus bt plus ct square. Okay, so this is there. Now dxt plus cxt is an, not writing this, they have written this, is an unbiased estimator of alt equals to m xt m underscore xt. So please, you can increase your font size, I only can't see, so increasing font sizes. Then alt equals to ln of m underscore brackets x comma t brackets close is equals to a plus bt plus ct square. So therefore alt equals to implies m underscore x comma t is equals to exp of a plus bt plus ct square, okay, which is equals to e to the power a, e to the power bt plus into e to the power ct square, so which is equals to a b to the power t c to the power t square. Okay, just power sign where, and now we'll just write where, since we have substituted for the values, where alt equals to a is equals to e to the power a, b is equals to e to the power b, and c is equals to e to the power c. Okay, so these are there. And revised projections of the cubic spline function. Again, this is there, some of this is there, so I'll just write it for you. Again, I'll just show you ln of dxt and ln of ecxt is there, so I'm not writing anything, already there with an equal to sign now in between, and with the other part now being plus backslash of sum underscore brackets j equals to 1 to the power capital J, okay, and backslash theta underscore j, b underscore j, and t. So these are the values under my this. So where j naught's position t1, t2 are to be written, and then bjt. So bj underscore t is equals to, you can write 0 for t less than t underscore j, and come down, and alt equals to, you can also write t minus tj q for t greater than equals to tj. Okay, so this is the mathematical typing only in this chapter, otherwise it's a theory chapter then. Okay.